So far, I've been using only Krakatoa particles, PRT volume, surface, and fractal, and so on. And you can use the PRT loader also. But all the things that we're doing actually apply to Maya particles too. So this is the example particle system that we've been using since day one in our tutorials online. I'll simulate it to about frame 100. So you see, everything is in real time, and I'm not even caching anything. So I'll go to frame 101. I'll select this system and I'll add a magma. And when you do this, actually you can see in the modifier that this is the particle shape, this is the magma, and we introduce another node, which is the PT Maya particle. That's a wrapper that converts the channels from Maya into our format, and then the magma can come here and do exactly the same thing. The only difference is you cannot really show the channels in the viewport. That means you have to render in order to see what's happening. But right now, if I render, these particles are not too many, and about 30,000, probably nothing to write home about. And I've been using an array mapper with a gradient ramp to create those colors. But let's say that I wanted to create a blend based on age. So red particles in the beginning, yellow particles in the end. I press Shift-Control-C for color, and then I say I want to do Alt-F-B blend. First color should be red, and the second should be yellow. And then the next input is the blend amount, and I'll use Shift-A for add age, divided by Shift-L for lifespan, and render. And here we go. This is the red, and this is the yellow, and I can actually shift this by taking it to the power of an exponent. With the exponent of 2, I get more red and yes, the yellow. If I go 0.5, we'll go in the opposite direction. It will be a lot more yellow, less red. So basically, this is overwriting the color channel that came from the RGB-PP in the particle system, and I can set pretty much any channel, read most of the relevant channels from the Maya particle system. We'll be working on exposing more and letting you expose any channel that you have. Right now, the list is relatively limited, but the important stuff like the color channel comes, and the age and the lifespan and the velocity and the positions, and that's what you need for typical calculations. So this is what we just did, and we can also draw a density by the same factor. So I'm going to remove this one, and I'll just say I'll create another Shift-Control-D is for density. I'll get this value, output it here, but this is not very good, because if I render now, the particles in the beginning will have density 0, and at the end will have 1. I want exactly the opposite, so I'll select this one, minus key, Control-W to swap it. Now we're subtracting from 1, which is the default for the first socket. And if I render now, particles will be blended out in the end and will be completely solid in the beginning. Now we have to talk about the order of operators, because if you do a repopulate, this is kind of an issue. If I do a repopulate after the magma, everything is cool. I hit the render button, and I'll get my red particles into yellow particles. And this is a relatively large radius. I can make it look finer by going to 0.05 and so on, but the principle is the same. I have this rendering, and it looks good. And if I evaluate the magma behind it, I'll move it down, and I'm not setting the density channel, only rendering the color. Everything will still look relatively fine. I'll move this magma up and render again. Actually, I'll capture this one and render again, and you see that there is no difference between the result with repopulate first or repopulate second. But this is not the same when the density is on. If I do the density on and render now, it's going to look good. I have red and then fall off. But when you do a repopulate, the density is actually distributed fractionally through all the new particles. So if you have a density of 1 here and you create 100 particles around it, each one will get 100 of that value. That means if the magma was applied after the repopulate, my density will be destroyed. Actually, I'll set the same density everywhere, and the whole thing gets overbright. So I have to keep in mind that the order here really, from top to bottom, matters, and it's also faster to first calculate the few particles with magma and then repopulate them to create 10 million or 100 million out of them, because all the channels will be distributed correctly and mostly will look good anyway. All right. Interesting thing to notice, when you're using repopulation is that repopulation actually also creates a normal channel that didn't exist before. These particles don't really have a normal channel unless you went and defined one with expressions within Maya. But let's say that we are rendering now repopulation, and this is the result that we were getting before. I'm going to add on top of this another magma, and in this magma I will override the color with the normal and render again. So now these colors that you see here are the actual normal vectors of each particle, and the normals are created because we create a grid and distribute the new particles. They're kind of taking the surface normal that you would get if you had a blob mesh around it. It's a similar result, like a level set, and you're taking its normal. So if you render this one with func shading, you're actually going to get correct specular highlights, might look as an actual blob. But an interesting thing that you can do with it is you can go and take this normal channel and dump it into the velocity channel, for example. I have to see if I have it here. Yeah, I have it. And it is the same particle system as we just dealt with, but with even less particles. I have a very few particles here. You can see them. And when I render, I'm repopulating. And I'm also creating the normal that was generated from the repopulation was copied into the velocity channel, multiplied by a really large value. Let me update here and show you. Here is what we do. We take the velocity that exists. We add to the existing velocity a new velocity, which will be the normal multiplied by 20, and we output as velocity. And then in the render settings, we set the render settings to a jittered motion blur with 8 segments. And the result is that each particle will be jittered randomly in a glow around the original position, and you get really nice sparks there. I have somewhere here a video of this, and I hope it won't play really well in the transition. I mean, in the transmission from GoToWebinar. But I hope in my recording that we'll be posting on YouTube, you'll be able to see it better. So this was actually created using about 300 particles and repopulate on top to simulate the glow. So this is yet another non-photorealistic kind of thing where you can jitter particles around through the motion blur to create completely new things. If you disable the jittered motion blur and just render with a few passes of motion blur, you can get a completely different look that looks like some waves around. So yeah, this is something that you can use Magma to create completely new things with it. And we can load again the previous particle system that had more particles. And where was it? Here it is, color and lifespan. So let's update here and add our Magma again. Let's say that you have this particle system. I'll simulate again to about frame 100, and you want to know if these particles are inside some volume or not. We have dedicated operators for that, and you can even abuse some of the other operators to do the same. So here, what I'm going to do is I'll create quickly some mesh. Once again, let's say it's let me see. Put the sphere here, enable the shaded mode so we can actually see where we are. And I'll make that sphere a little bit larger. You see that's already intersecting the geometry, but I'll make it bigger so it's clear what's in, what's out. Let's say 1 is a good size. So in this Magma here, we want to set the color, for example, to a different color depending on whether it's inside or outside. There is a special operator which is called in volume. Makes sense, and that outputs true or false. So what I need behind it is a switch, and this switch should take this as the third input, and the input here it's a geometry input as usual, and position in world space. So I'll go my scene, my sphere selected. I hit that button. Now that is there, and this switch needs 2 colors. Let's say again we'll go with red and yellow because they kind of show what we're doing, and then we hit the render button and hope that everything is as we want it. Yes, we have red inside the sphere and yellow outside the sphere. So this worked well, and you can make conditions. We'll say all the particles inside the sphere should disappear. Instead of doing a color, you can set the density to 0. The particles won't render. So I can pretty much skip them. I can draw, oops, I did color, I can switch it to density, and I can say this in volume will be a Boolean. So I convert that, a Boolean is coming as an integer 0 or 1. What I need is the density to be a float, so I'll do convert to float. And now inside is true and outside is false, so subtract from 1, I guess. I haven't really tested that, but yeah, I mean, you can see when the particles go into the sphere, they disappear because I set the density to 0, outside they're 1. All right, there is another way to do this, very similar way. We can draw a nearest point, the one that we use to steal data from the mesh, and we can reconnect to the existing geometry and existing lookup point. And there is a distance here, and this distance has a negative sign when the particle is inside the mesh and a positive sign when it's outside. So all we have to do is say, is this distance, logic, less than 0? This is 0, the default value. If it is, then we want the one color, otherwise the other, and it should produce exactly the same result. The cool thing about this is, instead of doing it as a Boolean, true or false, we can take this distance and normalize it. So I can say, okay, if the distance has a floating point value, all we have to do is divide it by the radius of the sphere. I probably don't even have to divide it because the radius of the sphere is 1 right now. And we'll take the absolute value of this. So it's positive inside and outside, and we'll blend the two colors. And we render now. Hopefully, we'll render. It looks like I forgot something here. Yeah, I need a Boolean. This is a switch. I need a blend. I thought this was a blend, but it wasn't. So a function blend. The function blend will have exactly the same inputs, the one, and let me switch to manual mode so it doesn't reorder anymore. The yellow will go here, and the absolute will go here, and the color will go there, and then we render, and what we get is red at the surface of the sphere with a gradient into yellow inside and a gradient into yellow on the outside. So that works also well. And you can do various tests like that. The other test that we want to talk about is moving particles to a surface of a node using Intersect Ray. So instead of doing all this color, or in addition to it, I'll delete all the nodes and start a new flow so it's clear what we're doing. I'm going to move this guy somewhat down there. So particles passing above the sphere will go to the surface of the sphere. I'll make the sphere probably a little bit bigger, so it's like a big dome. And I'll zoom out so we see more of what's going on. And I'll also create another mesh, which will be a plane approximately in the same area. That means we'll be intersecting with two objects this time. We have the sphere, we have the plane. We'll select both, and we use, once again, we'll say, this time we'll be setting the position, Shift-Control-P. We need the Intersect Ray, out or I. The position will be sent out, but we want that position to actually be in object space because the particle system typically is processed that way. Say input geometry and hit the get from selection, so both the shapes, the sphere and the plane come. And then if I select here, it says I want toward, and the ray intersection should go along the -y. And if I drag, you see that I'm already prepared for that, because very often you want to go either up or down. So that down vector is already here, you don't have to think about it. At this point, if I would render now, some things won't be exactly as we want them. You see that the particles that are above the plane and above the sphere are going there, but particles that didn't intersect anything actually ended up at 0, 0, 0 and created a big glow here. And that's something that's happening because if that intersection is invalid, the result of position is 0 instead of invalid, and the particles get sent there. I can do the isValid switch here and say, yeah, create a logical switch. That sounds good. And if it was valid, then take that position. If it wasn't valid, take the original position of the particle and keep it where it was. Get it out, render now, and then the particles in the beginning are okay, and when they go to the intersection, they're going to follow the plane, or I can go with this up and render, and particles are going above the sphere. So yeah, Intersect Ray in this case can be used, for example, if you simulated a particle system and then it has to follow some terrain geometry that wasn't there when the simulation was done, you can conform it to that surface, for example. Or you can just shoot rays down and figure out properties of the surface and translate them to the particles, but not change the position, change the color, basically, based on what the hues underneath are doing and so on. Or steal mapping coordinates and so on.